Hi students, good morning. I hope you all are fine. I hope you all completed your classes. Okay, I said already today we will start another one new topic. Okay, till now you not hear this word. So today we are going to have a new word. Okay, so that is permutation. Okay, shall we start the next section? Okay, section name is permutation. Have you heard this word before? I think this it's new for you. Okay, so first we'll learn what you mean by permutation and afterwards we'll move to the problems. Okay, first I will give one simple example for you. Okay, so now what we are going to do is, suppose we are going for one okay, let's I will explain the same book example. Okay, then only you will get some more idea. Okay, that is, suppose we have a fruit salad with a combination. So we have some fruit salad. Okay, in your home you are preparing fruit salad. You keep it in mind. So apple, grapes, banana, everything we will put for fruit salad. I'm right? Yes. We don't care what order the fruits are in. Okay, we don't care. If you will care about the order of the fruit salad, okay, otherwise you will go for any shop or anywhere and you are asking some fruit salad or some sarbat or anything you are asking, and you will ask the shopkeeper in which order you put all the fruits or vegetables. When you are asking vegetable salad or fruit salad, in which order you placed the fruits, you will ask anything? No, is it right? When your mother is giving a fruit salad for you, whether you will ask in which order you put the fruit salad? No. How they will put the fruit salad? All the fruits they will put it inside and they will give the fruit salad for you. Yes. So the same example they are giving in your book. So apple must be there, banana must be there, or grapes must be there. So whatever the orders are there, that's not problem. They could be also be bananas, grapes and apple, or grapes, apple, bananas. Which whatever the order may be, grapes, apple, banana, or apple, banana, grapes, in any order they can place the fruits. Here the order of missing is not important. Anyhow, we will have the same fruit salad. Have you got it, the idea? So the order is not important. Anyhow, we need the fruit salad. But in the fruit salad, what are the fruits must be there? Apple must be there, banana must be there, grapes must be there. So whatever is the order, that's not the problem. Okay. So in any order they can put the fruits. Okay, that's all. Then, but there is only one important thing. But there is one another condition. They are differentiating this example with another. Okay. But consider a number lock. The number lock having one. There is a number lock means that is a secret number is. So if it is a number lock, your number lock 395. Okay. If you make more than 3 attempts wrongly, what will happen? You are all using the mobile phones. Yes. All of you having a number lock in your mobile phones. Yes. So if unfortunately maybe you forgot your password. Okay. What you will do? Again and again, if you are putting the password again and again, what will happen? 3 times. Okay. 3 times afterwards, what in your display we can see? Okay, you can wait for 30 seconds, otherwise your phone is locked. Like that we will see, is it right? So same as that in number lock. So what will happen? 395. 3 times they will get a chance. Afterwards, what happen? It will say it will be locked permanently. Maybe in ATM, if you are taking the cash, if you are putting the password again, it will say, is it right? It is locked. So that's the same thing. In that situation, we do care about the order. That situation, we will care about the order. But in the fruit salad, whether you will care about the order? No. But in the number log, we will care about the order. The log will not the log will not work if you input correctly. If you are putting the wrong, it will not work. Okay. The number log will it will not accept if you are putting in correct order. Okay. So such a situation in our practical life. So here, so we should know the order of arrangement. This is called permutation. Now you got it. What is the permutation? So permutation means that we need to place something that must be order. Order is very, very important in permutation. Shall we move to the definition? So this example, so sometimes they will ask in the exam, define permutation. Okay, so at once fruit salad story, vegetable salad story, then the number lock story, that and all no need. Okay, just for your understanding, in your book they gave some examples, I explained. That's all. Okay, so now we will come to the definition. So all of you put the heading permutation. Permutation in your note. Then definition 2.3 you copy to your note. Okay, the number of arrangements that can be made out of n things taking or at a time is called the number of permutation of n things taken or at a time. Okay, n things taking or at a time. So this is number of permutation. The definition is very important. Down one more exam is there, that one only continue. So after putting the heading permutation, you need to take the definition to your note. Okay, then come to notation. The notation is if n and r are two positive integers, so that also you take to your notes. Notation, if n and r are two positive integers such that 0 less than or equal to r less than or equal to n, then the number of all permutation of n things taken or at a time is denoted by npr or p of n comma r. Okay, here this r must be in suffix. Okay, this is very important theorem. Proof is not given, so this is no need, but this statement is very npr is equal to n factorial divided by n minus r the whole factorial. Please children learn this, take your notes also. So what is npr? npr equal to n factorial divided by n minus r factorial. Understand? Okay, let's move to the question. Example 2.15. Evaluate 5p3 and p of 8, 5. Both also same thing. Okay. Okay. Solution 5p3. First, shall we find 5p3? What's the formula for npr? N factorial divided by n minus r the whole factorial. So here what's the n value? 5. R 3. Shall we substitute here? So 5 factorial divided by 5 minus 3 whole factorial. That's equal to 5 factorial means how will you write? 5 factorial divided by 2 factorial. So how will you write 5 factorial? 5 into 4 into 3 into 2 into 1 divided by 2 into 1. This and this will get cancelled. So what's the balance? 20 into 3? 60. The answer is 60. Have you got it? So using this one, if you need, you can write it on the side. npr is equal to n factorial divided by n minus r whole factorial. This is a formula you will use. Okay, shall we move to next one? That is p of 8, 5. So here p of 8, 5 means what's the meaning? N value 8, r value 5. Shall we substitute? So 8p5. That's equal to substitute. Same as that. 8 factorial divided by 8 minus 5 factorial. That's equal to 8 factorial divided by 3 factorial. So how will you write this one? 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 3 into 2 into 1 into 1. So these two terms will get cancelled. So multiply all the terms. Okay. First you multiply. Shall we multiply? Okay. 20, 5 4s are 20 into 7 into 6, 7 into 6, 7 into 6, how much? 6 into 6, 36, 42, 42 into 8. Now multiply every term, so you will get 6,720. Have you got it? Very easy. Okay, permutation, but only one formula. What's the formula? npr equal to n factorial divided by n minus r the whole factorial. Got it? Okay. So some results are there in your book. So all of you learn all the results. Okay. They will ask in one word question. Some problem also we will use this. Okay. So 0 factorial. What's the value for 0 factorial? What's the value for 0 factorial? 1. What's the value for 0 factorial? 1. Then np0. What's the formula will substitute? Is it right? N factorial divided by n minus r factorial. So n minus 0. So what you will get? n factorial divided by n factorial, both will get cancelled, you will get 1. Same as np1, what's the value? N factorial divided by n minus 1 factorial. Then in the previous section I taught you what's the value for n factorial? N into n minus 1 the whole factorial. So both the terms will get cancelled, n. Maybe in one word question they will ask what's the value for np1? What's the answer? N. Then npn means what's the value? You will get n factorial divided by n minus n factorial. All the things depending on only one formula we have learned already. Okay. N minus n. Okay, that's equal to n factorial divided by n factorial divided by 0 factorial, that's equal to n factorial. Then npr, what's the value for npr? Npr means what? N into n minus 1 into n minus 2. This you learned in last section, but last value see n minus r minus. Okay, so this also we will use in problem sometimes, but one word questions it's very important. Okay, let's move to the next one. 2.16. Evaluate 8p3, second one 5p4. Using the formula also you can follow, otherwise one more easiest method is there. So 8p3 means how will you write? 3, is it right? So 8, that's the n value, r at a time, that is 3 at a time. So only 3 values you will write and you will find the answer. If you need, you can use the formula. If you multiply, you will get 336. Otherwise, same as that previous you can use. Otherwise, this is very easy. Then 5p4 means up to 4 terms. Okay, so how much will write? 5 into 4 into 3 into 2. Multiply 5 4s are 20. 20 into 6 is 120. This is the answer. Got it? Okay, let's move to the next question. Example 2.17. In how many ways 7 pictures can be hung from 5 picture nails on a wall? How many ways 7 pictures can be hung from 5 picture nails on a wall? Okay, so 7p5. Seeing the question itself, you come to know that 7 pictures can be hung from 5 picture nails. So 7p5. Okay, but you need to write one step, that is solution. The number of ways in which 7 pictures can be hung from 5 picture nails on a wall is nothing but the permutation of 7 things taken 5 at a time. Okay, that is 7p5. Okay, that is 7p5. 7p5 means how will you write? Using the formula you can find, that is 7 factorial divided by 7 minus 5 factorial. So how much will get? 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 5 minus 7 minus 5 means 2, is it right? So 2 into 1. So this and this term will get cancelled. So multiply all the terms. 7 into 6. 7 into 6 means 42. 5 4s are 20. 20 into 3 is 60. So multiply 42 into 60. So 2520 ways. That's it. Got it? Let's move to next problem. Example 2.18. I am reading the question. Find how many 4-letter words can be formed from the letters of the word logarithms. Okay. So words are with or without meaning. Maybe with or without meaning. No problem at all. Okay. So how many letters are there in logarithm? So you take down the question from your book. Solution. How many letters are there in logarithm? So there are how many letters? 10 letters. Okay, there are 10 letters in the word logarithm. Logarithm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay. So therefore, what's the n value? What's the n value? 10. Okay. So we need to find how many letter word you need to find? 4 letter word. So R value 4. Is it right? So we need to find. We need to find 4 letter words. So R value is equal to 4. Yes. So how will you find the required number of 4 letter words? Hence the required number of 4 letter words is equal to NPR. Okay. That is equal to N value is 10. P R value 4. That's equal to 10 into NP4 means 10 into 9 into 8 into 7. Okay. Now multiply, how much you'll get? 5040. Got it? 5040. Multiply and see its answer. Okay. That next problem, example 2.19. If NPR is equal to 360, find N and R. So here, see, we don't know the value for N and R. We need to find N and R. But only one thing is given, NPR is equal to 360 they give. So first we need to split this. NPR is equal to 360. Shall I write this as 36 into 10? Okay. So same as this one, we can split as 36. How will you split? Shall we give for 3? Okay. Then 1, 2, again 3. 4. Correct? Then 10 how will you split? 5, 2. Okay, we are going to write like this. 3 into 3 into 4 into 5 into 2. So, now listen. 3 into 2 means how much will get? 6. Is it right? 5 into 4 into 3. So, last class I taught you same as like this. Is it right? So, NPR. So, we can split like this. So, this one how will you write? 6P4. Shall we write like this? 6P4. The step shall we write like this? So what's the N value? 6. What's R value? 4. Got it? So important 2 mark. I will repeat again. That is NPR is equal to 360 they gave. So the 360 how I have changed? 36 into 10. Again I split it. Then next how I wrote? 6 into 5 into 4 into 3. So this one I can write as 6P4. Is it right? So N is equal to 6. R is equal to 4. Got it? Okay. Let's move to the next question. Next one is permutation of repeated things. Okay, we are going to learn permutation of repeated things. Now we have learned permutation. So next we are going to learn permutation that is repeated. So since till now whatever you learn in each and every question, is there any repetition is allowed? No, there is no repetition. Is it right? So logarithm means there is no repetition. So like that we have learned. So then we are going to learn permutation of repeated things. Permutation of repeated things. Okay. The number of permutation of n different things taken r at a time when repetition is allowed is n power r. Repetition allowed means what's the formula? N power r. So this line you can take to your note. I am reading that line, you need to take to your note. Okay. The number of permutation of n different things taken r at a time when repetition is allowed means what's the formula? N power r. Okay, keep it in mind. This is a formula. So first you have learned one formula when repetition is not allowed, that is NPR is equal to n factorial divided by n minus r the whole factorial. So this one, what's the formula? N power r. So example 2.20. using 9 digits from 1, 2, 3, etc. up to 9, taking 3 digits at a time. How many 3-digit numbers can be formed when repetition is allowed? When repetition is allowed. So what's the formula? N power r. Is it right? So here what's the n value? Solution. Here what's the n value? Using 9 digits. So what's the n value? 9. How many digits they said? R is equal to 3 digits. So what's the formula? Number of 3 digits. Numbers equal to n power r. What's the, that is 9 power 3. That's equal to 9 power 3 means how much you will get? 9 into 9 into 9. So how much you will get? 729 numbers. 729 numbers. So 9 into 9 into 9 means 729 numbers. Have you got it? Okay. So next we are going to learn permutation when all the objects are not distinct. That is not different. Okay. So we will learn this. So here also we are going to learn one formula. I am reading the number of permutations of n things taken all at a time, of which p things are of one kind and q things are of another kind. Understand? So one of one another kind, one is another kind. So both also different. So first you learn non-repeated, next you learn repeated, their own formula. Then for this one both are not distinct. Okay. Then things are of another kind, such that p plus q is equal to n is, what's the formula you use here? That is n factorial divided by p factorial into q factorial. In general another one, that is third kind, that is one more thing is given. Okay. So if it is 3 things are there means what's the formula? N factorial divided by p1 factorial, p2 factorial, etc. pk factorial. So please students put the next heading, permutation when all the objects are not distinct. Put the heading, and in your book 5 lines are there. Copy that to your note. Okay, 5 lines are there. Now I have read out. So that 5 lines you need to copy to your note. So there 2 formulas are there. We will use that. Okay, got it? Okay, let's move to the question. Example 2.21. How many distinct words can be formed using all the letters of the following words? What's the first one? M-I, S-S-I, S-S-I, P-P-I. Okay. Second one, M-A-T-H-E, M-A-T-I-C-S. Okay. First one. How many letters are there in this Mississippi? Okay. Solution. How many letters are there? There are 11 letters. There are 11 letters in the word Mississippi. Mississippi. Okay. So in your word, M occurs how many times? In this word, M occurs how many times? M occurs once. Is it right? Then I occurs how many times? 4 times. Correct? Whether 4 times is there? 1, 2, 3, 4. Then S occurs how many times? 4 times. Correct? Okay. Then P occurs how many times? Twice. Okay. So therefore the number of permutation. Permutation. What's the formula? I said already, n factorial divided by p1 factorial, p2 factorial, etc. pk factorial. So how much is there? You can use that. So n factorial totally 11 is it right? So 11 factorial divided by m occurs once is it right? So 1 factorial 1 only. Then 4 I occurs 4 factorial. Then s occurs 4 times, that is 4 factorial. P is 2 times. Okay. So you can simplify this, otherwise you can leave as it is enough. Second one, in this word, in the word, what's the next word? Mathematics. Mathematics. Okay. There are how many letters are there? There are 11 letters. Okay. Okay. M occurs how many times? 1, 2, 2 times. Okay. 2 times. Okay. Next, A occurs how many times? 2 times. Then T occurs how many times? 1, 2 times. Okay. So 1 times, those are the letters 1 times occurring, we can leave that. Why means if you are substituting there in the formula also, you will get the answer 1. Okay. So because of that you have doubt. Why ma'am? That M, T alone you are taking, remaining E and all you are not taking. So E means only 1 time, is it right? So 1 factorial only. C means that's also 1. So more than 1 means that alone you can consider. Okay. So what's the formula? Different numbers. So the permutations is equal to n factorial, that is 11 factorial divided by 2 factorial, 2 factorial, 2 factorial. If you need, you can write everything 1 factorial, 1 factorial, 1 factorial. Both are everything same answer, 1 only you will get. Because of that we left. Understand children? Okay, I hope you got good idea. So what are the things we have learned today? So I introduced a new section, that is permutation. Next, whatever you have learned, repeated, not repeated and distinct. 3 formulas you have learned. NPR equal to n factorial divided by n minus r the whole factorial. Next, n power r, that is repeated things. Next one, distinct means n factorial divided by p1, p2 factorial, etc. up to pk factorial. 3 formulas we have learned, some problems we have completed. So now it's the time to do the homeworks for you. Okay, all are ready? Okay, take down exercise 2.3. 2.3. So problem number 4 is a homework for you. Okay. So today that's only one problem is a homework. So homework is exercise 2.3, problem number 4. Okay. How we need to do is same as this problem. Okay. Now last we have completed this same as this one we need to do. So here one more section is there, circular permutation. So the circular permutation I will taught you in the next class. Okay students, please completed the classes as well as completed this homework. We will meet in the next class with the next new topic, circular permutation. Be safe.